What if the Victorians reached the moon? History changed. Picture this: a brass-plated capsule, rivets gleaming under gaslight, rising above the London fog while crowds on Westminster Bridge stare up, hats blown back by the roar. Telegraph lines hum. The Thames catches firelight from an artificial dawn. And somewhere high above the clouds, the Union Jack drifts in weightless silence as the moon swells in the window, like a pale coin. If that sounds like a fever dream from Jules Verne, buckle in. Tonight we're going to step into an alternate history where the Victorians don't just imagine the moon, they reach it. First, a reality check. What really happened in our timeline? The 19th century was an age of steam, steel, and stunning ambition. Railways stitched continents together. Telegraphs stitched minds together. We got anesthesia, antiseptics, and the slow birth of modern public health. Photography captured time. Spectroscopy dissected light. Astronomers mapped craters on the moon by hand, sketching the night like cartographers of the sky. But the rocket belonged to fireworks and battlefields. The math of getting to space, of escaping Earth's grip, would wait. Konstantin Tsiolkovsky, a Russian schoolteacher, published the rocket equation in 1903, proving that to reach orbit you need staged rockets and high-energy fuel. Liquid oxygen would be liquefied in the 1880s. Dewar flasks would tame the cold in the 1890s. Radio would crackle to life under Hertz and Marconi. But none of it connected in time to put humans beyond the Kármán line before the 20th century took hold. Real spaceflight emerged out of 20th century storms. Goddard's experiments, V2 Terror, the Cold War, Sputnik, and finally Apollo in 1969. So how do we bend that river? How do we push the leap to the moon backward, into the age of brass and steam, without drifting into pure fantasy? We start with a spark, and then we feed it oxygen. Our divergence begins in 1851 at the Great Exhibition in London. The Crystal Palace is a cathedral of industry. Inside, a demonstration of Congreve rockets, descendants of Indian Mysorean designs, captures the attention of two minds that rarely meet. Isambard Kingdom Brunel, titan of steel and motion, and a prickly visionary mathematician who never quite gave up on Charles Babbage's mechanical dreams. Call him a collective. The generation of engineers and calculators who believed machines could think in gears. They walk past steam presses and iron beams and ask a subversive question. What if a rocket didn't just arc and fall? What if it sustained its own climb? They begin convening, quietly, under the Royal Society, in a committee that sounds ridiculous even as it forms, the Astronomical Subcommittee of the Royal Astronomical Society. The phrase is a joke at first, then it isn't. A handful of conditions in the Victorian world make this crazy plan barely plausible. First, guidance. In the 1850s, Léon Foucault shows off the gyroscope, proof that a spinning wheel remembers direction. Victorian engineers can build gyros. They can spin them with belt drives, balance them with precision bearings, mount them in gimbals. Next, materials. The age of Bessemer and Whitworth means strong, uniform steel, riveted pressure vessels, and the first obsessive tolerances. Then, chemistry. The century is intoxicated with explosives. Nitroglycerin becomes dynamite. Oxygen is liquefied by Pictet and Cailletet in the 1880s, and James Dewar's vacuum flasks make storing cryogens thinkable. Finally, communications. By the 1890s, radio is born. A rocket can talk to Earth. Still, none of that is enough without the cruel friend of progress: money and fear. Enter imperial rivalry. The British see Russia expanding across Asia. The French dream of glory after 1871. Germany industrializes like a storm. The United States looks across the Atlantic with restless energy. When a sensational meteor over London in 1869 ignites public imagination, sending an eerie daylight across the city and scaring Parliament into emergency debates, something breaks free in policy. The Astronomical Society's Wild Committee gets funding. At first, it's all about mapping the upper air and national prestige, but it's rocket money all the same. The 1870s produce failures that write manuals. Solid propellants are too dirty, too unpredictable. Early liquid experiments, alcohol and compressed oxygen, blow up test stands and scorch the backs of workshops along the Thames. But by the 1880s, the committee has learned 3 hard lessons. 1. Multi-stage is non-negotiable. 2. Kerosene and liquid oxygen burn with a fury that steam and air cannot match. 3. Gyroscopes, when coupled to mechanical vanes in the exhaust flow, can make a rocket fly straighter than instinct suggests. You can almost feel the language evolving. No longer fireworks, vehicles. A new word begins to circulate in newspapers with skepticism and glee: spaceship. By 1892, after a decade of quiet failures, a 2-stage demonstration reaches the edge of space, telemetry chirping in Morse as pressure and temperature climb and then flatten into silence. No one can agree on where space begins, but the headlines agree on something else. The British Empire has opened a door. The Germans form their own astronautic Verein. France pledges a national laboratoire for cryogenics and high-altitude research. The Russians dig in Siberia. The Americans put a rocket range in the Nevada desert, where the land can be bought cheap and the sky feels eternal. What changes first? Not the moon. The atmosphere. Meteorology rockets bloom. Weather balloons grow brains. Fleet admirals start listening to radio reports from the stratosphere. Telegraph companies develop relay rockets to jump signals over mountain ranges. And then comes the obsession that no politician can resist: reconnaissance. A camera loaded with glass plates and then celluloid film sent up to bring back the shape of a rival's harbor. It takes a longer arc and brutal recovery techniques, parachutes and ships waiting in currents. But each success funds the next dream. The leap to Earth orbit is the test that should break the Victorian era. It requires not just power, but precision. It requires staging that peels away like a metal flower in the sky. It requires pumps that drink cryogens without seizing and seals that hold against fire. But watch the industries that rise around the dream. Needle valve makers become precision pump designers. Lighthouse keepers get retrained as radio operators. Shipbuilders apply their craft to capsules. And then there's the quiet revolution in math. A class of human computers, mostly women trained in observatories and universities, perform orbital calculations by hand and on machines descended from Babbage's abandoned dreams. They become indispensable, anonymous, and, slowly, recognized. On a cold night in December 1900, as the century tilts, the British attempt the unthinkable, a crude lunar flyby. Not a landing, no one can land and leave again yet, but a slingshot around the moon and back to Earth, in a capsule bristling with gyros, barometers, and a crude radio spar. The rocket is a 3-stage spear, burnished and brutal, fueled by kerosene and liquid oxygen, its turbopumps whining like demonic organs. They name it Victoria. It is, if we're honest, reckless. But the world is watching. The ground heaves. The first stage burns a column in the sky and peels away. The second rides for minutes that feel like hours. The third shudders and then steadies into a silence so complete that the crew can hear their own breath. Earth falls away. The moon rises like a truth. It is not pretty. The crew is nauseous, cold, and bruised. One of them, a naval officer chosen for stubbornness more than kindness, vomits into a bag and laughs through tears. They read the Lord's Prayer over crackling radio and then, halfway behind the moon, lose contact entirely. The next day, a photograph comes through, grainy, ghostly. The first view of Earth is a globe. It is small. It is alone. And it is devastatingly beautiful. The Victorian moon flyby works. Barely. The capsule slams into the Indian Ocean days later, scorched and dented, its parachutes in shreds, its crew pulled half dead onto a British cruiser. There's a speech at the Royal Institution. There are medals. And there is a quiet line of widows from the test stands who declined the ceremony. Now the world changes with a speed that would frighten even futurists. The British claim a first, but they cannot own the sky. Germany pours money into a mathematician-led rocketry program that treats guidance as a religion. France treats space as an art of display and weather control. The United States, flush with industrial strength and a taste for spectacle, builds the first reliable orbital platform by 1908, a plotted, procession-controlled satellite that relays radio across oceans. In our world, a family in Kansas won't hear live voices from London until mid-century. In this world, a farmer on the American plains turns a crank and listens to a Paris orchestra play for the new year, 1910. What happens to geopolitics when you can see from above? Borders harden and soften at once. Nations learn to spy with telescopes that drop film canisters for daring mid-air recoveries. Navies refuse to sail without weather rockets telling them the fate of storms. Colonial administrators tighten their grip, thinking they can see everything. But radio works both ways. Anti-colonial leaders eavesdrop, teach themselves, and coordinate with voices that skip across the sea. The same satellites that tie empires together give subjugated peoples a wire to pull. At home, culture changes. The Earth from space photograph becomes a lithograph in homes from Glasgow to Calcutta. Children memorize the clouds like saints. Painters rediscover blue. Poets talk about the unity of life, and preachers wrestle with a flock now confronted by a planet that looks fragile, finite, and undeserved. And then 1914 arrives, inevitably. War would not be prevented by perspective. It rarely is, but its shape shifts. With rocketry and early satellites in play, all sides enter the conflict with tools unknown to our history. Reconnaissance from orbit tells generals where the enemy sleeps. Rocket artillery, crude, terrifying, and wildly inaccurate by our standards, reaches farther than railguns, delivering explosives and, in darker moments, gas. Air defense becomes a science. Think of wooden towers on the coast, packed with gyroscopes and tripwire electronics, listening stations that triangulate a rocket's scream. Radar emerges early under pressure, the need to hear the sky made urgent by the fire that comes from it. Does this make the war shorter or longer? The barrage at the Somme comes with rocket salvos that pulverize not just trenches, but the towns behind them, terrifying civilians into panics that shake governments. And yet the visibility from above ruins surprise. No one can truly hide a massing army anymore. Attempts at glorious breakthroughs get canceled by maps drawn in orbit. Maybe, in this world, the front still grinds, but the stalemate shatters earlier under fear of escalation. Perhaps by 1916, a negotiated peace takes shape, a peace born not of mercy, but of sheer dread of what the next rocket might carry. Technology, whipped by war, leaps forward. Vacuum tubes scale up. Analog computers feed ballistics tables. Women computers move from observatories to war rooms, then to universities, then to industry. The pause after the peace is not gentle, it is feverish. Every major power looks up and sees not just the moon, but the prestige of putting boots on it. Landing, real landing with ascent back home, will require something the Victorians barely touched. Closed-loop control systems that adjust their own corrections on the fly. This demand becomes the quiet parent of digital computing. By the 1920s, New York reads the morning news via satellite relay. Weather forecasts stop being folk wisdom and start acting like prophecy. Commercial flights plot through jet streams with a confidence that saves lives and fuel. Farmers in India listen to monsoon warnings. A boy in Lagos hears a blues recording from New Orleans and picks up a guitar. Culture cross-pollinates decades early, for better and for wild. The first human footsteps on the moon? Not 1969. Not in this world. In this timeline, they echo in 1938 on a desolate basalt plain the Victorians called the Mare Tranquillitatis, under a flag crisp as law. The craft is austere, steel ribs wrapped in fabric and foil, tanks like drums, an ascent stage that resembles an oversized stove bolted to a chair. The astronaut's suit is a patchwork of rubber and cloth, pressurized by brute force, cooled by ice and a prayer. His life depends on machines whose tolerances were filed by hands in factories along rivers that once drove mills. He spends 90 minutes outside. He returns shaking, frostbitten, and permanently altered. Here's the twist. That step does not unite the world, it divides it. Colonial subjects listen to broadcasts of lunar pride from capitals that deny them votes. Activists reframe the moon not as a noble human achievement, but as the highest tower of empire. A generation of artists paints the moon black, a mirror held up to power, and yet it also seeds something impossible to control, a planetary identity that refuses to be claimed by any flag. The first internationalist movement to truly capture the masses is not Marxist or liberal. It is lunarist, an ideology that says the moon belongs to everyone because we all live under its pull. The economics bite hard. Rockets demand rubber, nitrates, and metals, and those demands intensify the ugliest labor systems on Earth. Congo's rubber terror deepens under quotas justified by national progress. Miners in Bengal die in shafts to feed cryogenic pumps. Newspapers do not print those photographs next to triumphant launch spreads, but word gets out. Radio whispers. Photographs leak. A moral backlash grows that will, in time, change the map faster than any army. Even the environment speaks up. Early launches blacken skies over ranges from Nevada to the Hindu Kush. Forests near test sites die in heat waves of exhaust. The Victorians, who never named smog by its modern name, learned to watch the wind. Then, in 1903, 3 years after the British flyby, a second nation's attempt ends in a night that looks like sunrise. The explosion rocks a coast. Windows break for miles. Hundreds die. It becomes the first global warning, carried by radio and telephone and the printed word to a species suddenly aware that new technology can kill at a scale never imagined. Yet, to stop would be to admit that fear rules. And the one thing the 19th century taught its children is that fear can be tamed by control. So they design safer valves. They invent redundant seals. They build escape towers. The grim count falls. A profession is born. Astronaut, a sailor of the void, as respected as an admiral, as disposable as a miner. Pause with me here. Does this world thrill you or chill you? Do you imagine an earlier moon as a mercy that might have softened our brutalities, or as an amplifier that made them ring out across the sky? I want to hear your take. Tell me in the comments which domino you think falls first: war, decolonization, computing, or climate awareness, and why. And if you want more alternate timelines unraveled like this, tap like and subscribe. It helps us keep digging into the fragile gears of history. By the 1940s in this timeline, Earth has 3 small lunar outposts, not bases in our modern sense, but shacks of metal and willpower. Each is serviced by rockets that look more like towers than ships. They do not extract resources yet, too hard, too costly. But they plant instruments. Seismometers listen to impacts. Telescopes stare outward without air to blind them. A tiny radio emplacement powered by batteries that have to be swapped every mission beams signals back to Earth. The most important of those signals is a sound familiar to our world's mid-century, a heartbeat that says simply, "We are here." Space begins to change Earth's politics in a subtler way. Timekeeping, now tied to orbital passes, grows precise. Trade tightens. A global economy, which in our world blooms after World War II, arrives earlier in fits and starts. Crashes happen sooner. The crash of 1921 is worse, but recoveries learn new speed. Insurance is invented for satellites, and the legal idea that something can orbit above a country without belonging to it becomes a doctrine. Space law, born in courtrooms that still smell of coal dust, stabilizes relationships that would otherwise tip into war. Science leaps too. Early orbital observatories discover hints of cosmic rays, map the sun's tantrums, and lay clues that will guide the future. The cosmic perspective, the photograph of Earth as a whole, the experience of looking down at weather like breath, infects philosophy. Environmentalism emerges decades earlier, not out of forests alone, but out of orbits. A movement takes root that says, in the clipped cadence of pamphlets, we share this thin air. And what of art? If you've ever seen the curves of Art Deco, imagine them born a generation earlier out of rocket dreams rather than ocean liners. Cities sprout observatories shaped like bullets. Train stations emblazon rockets on their rotundas like modern coat of arms. Waltzes written for balloon dances in the 1890s give way to suites composed for launch days, orchestras playing crescendos to match the roar of engines. The brass age becomes the burnished age. Not all is romance. Accidents continue to haunt. Scandals of cost and corruption topple ministers. An astronaut is caught on camera, grainy, unkind, crying in a capsule as a valve jams and a mission aborts. Newspapers turn it into a national debate about heroism and mental health in an era that pretends both are simple. The public discovers that courage looks very human up close. As for decolonization, it does not pause. It accelerates paradoxically under the surveillance of satellites. The ability to broadcast injustice makes it untenable faster than imperial pride can heal. The same rockets that once carried flags into the sky carry pamphlets and parachutes over cities that will soon be independent. Independence Days are celebrated under satellite broadcasts that stitch continents together in real time. New nations take over ground stations and add their voices to the sky. By mid-century in this timeline, a child holds a school globe that includes not just lines of latitude and longitude, but the tracks of satellites. She can name the week when a lunar seismometer heard a meteor hit. She can listen to a recitation of the Quran from orbit, followed by a lecture on Newton, followed by a blues riff played in a studio 3 continents away. Her world is wired not just by copper and glass, but by emptiness made useful. Would we be kinder knowing so much sooner how small our home looks? I want to say yes. History suggests otherwise. But here's what I think would happen, and what does happen whenever we build new vantage points. We learn faster. We see our mistakes in wider context. We invent new ways to collide and new ways to cooperate. We learn to picture humanity as one thing and 1,000 things at once. That doesn't cure violence. It makes it harder to justify. So, what if the Victorians reached the moon? Our world would have been louder earlier. The sky would have been busy long before Sputnik. Weather would have become a discipline of numbers, not folklore. War might have burned hotter and shorter in the first round, and perhaps later generations would have learned to be cautious a little sooner. Empires would have stamped the moon with their pride and discovered, as they always do, that the moon cares not at all. We'd have paid a heavy price, lives lost in tests, forests lost to flames, resources pulled from the earth with greed justified as destiny. And yet we'd also gained something hard to quantify, a longer season of seeing ourselves from above. More time to feel the truth that the Victorians barely glimpsed in foggy London nights, that the universe is vast, that we are not quite in charge, and that the small blue world under the moon's shadow is, against all odds, home. History is a stack of fragile hinges. Change one bolt, and you tilt entire centuries. The Victorians had the iron, the math, the fire, and the will. In another branch of time, they also had the push. And somewhere, under a gaslit sky, a brass capsule really did rise, or almost did. That almost is the space where imagination lives, and where we learn how close our reality came to being something we can barely believe.